Welcome to the SmartKeys podcast. So imagine writing some code on a Monday, right? And by Friday, it's accidentally denying loans to thousands of qualified applicants.
Yeah, that is a complete nightmare scenario.
It completely erodes your brand's reputation over a single weekend. I mean, we are diving into a comprehensive resource today by Felix Römer, and it's all about implementing ethical AI practices in business.
Which is basically the ultimate playbook for modern professionals right now.
Exactly. Because you're navigating this incredibly tricky balance. There's this intense pressure to move fast with artificial intelligence, but you obviously don't want to break the company in the process.
And that tension is really tearing boardrooms apart. I mean, you have this crushing mandate to integrate generative AI because, well, your competitors are doing it.
Right. The market demands that efficiency.
But rushing those deployments creates these massive, really expensive blind spots. Like a controlled test environment might look completely flawless.
Sure, in a vacuum.
Right. But then you push that model to live production without a solid framework, and suddenly those subtle flaws are operating at an enterprise scale.
And the numbers actually back up that hesitation. Römer's research points out that 80% of business leaders cite things like explainability, ethics, bias, or just trust as major barriers to their generative AI adoption.
They see the potential, but they definitely see the public cautionary tales too.
Oh, absolutely. I mean, we all remember Microsoft's Tay chatbot, right? It turned toxic within hours of public exposure. Or the COMPAS algorithm predicting recidivism rates with those severe racial disparities.
Right, and these aren't just IT headaches. They are structural failures that bring immediate regulatory scrutiny right down on your head.
And when those failures happen, brand trust just evaporates instantly. You can't treat AI deployment like traditional software where you just, push a patch for a bug after the fact.
No, because traditional software is deterministic, like
Yeah.
if this, then that. But AI is probabilistic.
It's making educated guesses based on patterns.
Exactly. So if you deploy a probabilistic system without governance, you aren't just moving fast, you're basically driving blind. You really need organizational brakes.
I love that analogy. It's like building a high-speed sports car without brakes. The brakes aren't there to slow you down. They're there so you can drive fast safely.
That's exactly it. They let you corner at incredibly high speeds without spinning out.
So if the goal is cornering at high speed safely, we need to look at how those brakes are actually manufactured and installed across the business. We're talking about AI governance.
Right, and governance in this context, it's the end-to-end oversight of intelligence systems.
Not just a final check before launch.
No, not at all. It's not an isolated review board looking at a finished product right before it goes live. It integrates into the entire life cycle.
Say from the very beginning.
Yeah, from the moment leadership says, let's build an algorithm to solve this problem, all the way through data sourcing, development, live deployment, and even the eventual retirement of that model when it's no longer useful.
So the source material heavily emphasizes these, what it calls artifacts of accountability, things like model cards, data sheets, and risk logs. But let's actually visualize this.
Right.
If I'm an engineer, what am I actually putting on a model card? Is it just like a compliance checklist?
It's much deeper than a checklist. I mean, think of a model card like a highly detailed nutritional label, but for an algorithm.
Oh, a nutritional label. I like that.
Yeah, it actively documents the intended use cases and, honestly, just as importantly, the explicitly prohibited use cases.
So what you absolutely shouldn't use it for.
Right. And it breaks down the demographic composition of the training data. It lists known performance limitations, processing latency metrics, and the specific bias tests that were run prior to launch.
So if you're launching, say, a voice recognition tool,
the model card documents the testing done to ensure it understands different regional accents equally well. You're creating a traceable, auditable record of every single decision made during development.
which ties directly into the non-negotiable principles Römer outlines, like fairness and transparency. The focus shifts entirely from reactive fixing to proactive designing.
Exactly. You aren't just hoping the model is fair when it goes live.
Right, you are establishing concrete acceptance criteria for your data sets before a single line of training code is even written. You're building transparency into the pipeline.
So a human auditor can actually understand a high-impact automated decision later down the line. It forces a really necessary cultural shift.
By requiring human rights and basic due process to be integrated by design, right?
Yeah, you align the technical development directly with the company's stated ethical policies from day one.
Okay, I hear the theory. But if I'm running a lean team in a hyper-competitive market requiring my developers to write extensive data sheets and maintain risk logs for every minor iteration. Well, that sounds like a bureaucratic nightmare.
It does sound like one, sure.
Right. Doesn't mandating data sheets and model cards for every step just create a bottleneck that kills the very innovation we're trying to achieve?
We actually see the exact opposite in practice. Without these artifacts, every new AI project becomes this chaotic, sort of bespoke science experiment.
Just making it up as you go.
Yeah, and developers get paralyzed because they don't know where the boundaries are.
Yeah.
They're terrified of accidentally deploying the next massive PR disaster.
Okay, so it gives them a safety net.
Exactly. When you standardize the processes, when everyone shares the exact same language for fairness and transparency, you actually remove the uncertainty. Teams experiment faster and more freely because the guardrails are clearly defined. You operationalize the innovation.
The documentation only gets you so far, though. I mean, you can have the most beautifully formatted model card sitting on a company intranet, but if the model hallucinates and costs the client millions of dollars, a PDF isn't going to fix it.
Yeah, definitely not.
We have to look at who is actually enforcing these rules, which brings us to the who of governance.
Right, because accountability is really the engine of governance. If risk belongs to everyone generally, it essentially belongs to no one specifically.
That makes total sense. So who should be owning this?
Well, board members and the CEO have to set the initial tone and, provide the funding. But the day-to-day oversight requires a highly integrated team of shared stewards.
Like legal, risk, audit, and data leads locked in together.
Exactly. In fact, Römer notes that 80% of organizations now have a dedicated risk function specifically to handle this kind of oversight.
Wow, 80%. The article also leans heavily into the RACI framework here. And I think most professionals are familiar with RACI, responsible, accountable, consulted, and informed from standard project management.
Sure, but that usually applies to predictable tasks.
Right. So how does a RACI matrix change when we apply it to a neural network that makes totally unpredictable, probabilistic decisions?
It requires a much more granular approach to ownership. Think about it. In traditional software, the developer who wrote the broken code is responsible.
Simple enough.
But in AI, if a model makes a biased decision, is the person who trained the model responsible? Or is it the person who sourced the data?
That's a really good point. The blame is a lot harder to assign.
Right. So the REI matrix for AI explicitly defines ownership for each specific artifact and outcome. Like, who is responsible for running the adversarial bias test? Who is accountable for signing off on the final release?
And which legal expert needs to be consulted when the use case shifts slightly, right?
Exactly. Or which customer service lead just needs to be informed when a monitoring alert triggers a change in how a chatbot behaves.
So instead of a traditional software assembly line, it really is more like a professional kitchen brigade.
A kitchen brigade.
Yeah. If everyone is just throwing ingredients into the AI pot, the soup gets ruined. You need to know exactly who is chopping, who is cooking, and who is taste testing the final dish before it reaches the customer.
I love that. And in that scenario, the internal auditor is basically the health inspector.
Right?
The framework demands that auditors have real, unhindered authority to access the systems, the code, and those underlying data sets.
So they need teeth. If they find an issue, they need the power to halt deployment.
Absolutely. Regardless of the intense pressure from the business side to launch. Empowering those cross-functional stakeholders to escalate issues early is really the only way to manage risk at that kind of speed.
Sticking with the ingredients for a second, even a world-class team cannot output reliable results if the inputs are compromised. Which brings us to the actual bedrock of any trustworthy AI system, data stewardship.
Right. You really cannot decouple AI governance from data governance. The life cycle of your information is a first-class concern here.
So we're talking about establishing rigorous rules for data quality.
Quality, yes, but more importantly, data lineage.
Lineage, like tracking where it came from.
Exactly. Lineage means tracking a piece of data from its origin through every transformation, cleaning, and aggregation, all the way to its final state inside the model.
Because if a data set is later found to be compromised or biased or even legally non-compliant,
You need to know exactly which models ingested it so you can pull them down immediately.
the text also highlights data minimization, which I found interesting. Instead of the old tech habit of hoarding every terabyte of user data just in case it's useful later, you only collect the specific personal info necessary for the model to function.
And you document that specific purpose. It inherently shrinks your attack surface and builds privacy right into the foundation.
coupled with strict retention schedules and robust access controls, I imagine.
Oh, definitely. We're talking about role-based permissions and data segregation.
Yeah.
You have to ensure sensitive customer information isn't just floating around in unprotected experimental sandbox environments.
Right. And the piece of this deep dive that really alters the traditional software mindset for me is this idea of continuous risk management. Römer stresses that risk isn't just a one-time deployment checkbox.
Not at all. Deploying the AI is not the finish line. It is the starting gun.
You need an active register of all models, continuous stress testing, and automated monitoring. And he points specifically to the danger of drift, which I have to ask for some clarification on.
Sure, drift is huge.
If a system was perfectly fair and accurate on launch day, how exactly does a model drift over time? And what does that actually look like for a business relying on it?
Drift is perhaps the most insidious threat to a deployed model because it happens completely silently. See, a machine learning model is trained on historical data.
So it's like a mathematical snapshot of the world at a specific moment in time.
Exactly. But the real world is incredibly dynamic. It changes.
So the underlying properties of the data coming in change over time.
Yes, and that is the first type, which is called data drift. Say you have a financial model assessing loan risk, right?
Okay.
If a sudden economic shift happens, like a recession or a massive change in interest rates, the incoming profiles of your applicants look fundamentally different than the historical data the model actually learned from.
So the underlying variables have shifted and the model's predictions start to degrade.
Exactly.
Okay, so the data coming in changes. But what if the data itself stays relatively stable, but the world's expectations change?
Then you face what's known as concept drift. This is where the human definition of the target variable changes.
Can you give an example of that?
Sure.
Huh.
Imagine you have an old map of a rapidly growing city. The physical map itself hasn't changed at all.
Right, it's the exact same piece of paper.
But because new highways and subdivisions were built in the real world, following that old map will drive you straight into a brick wall. The relationship between the input and the output has fundamentally altered.
Oh, I see.
For instance, consider an AI trained to detect cybersecurity threats. The definition of a normal network pattern changes as a company adopts new cloud tools.
So if the model isn't updated, perfectly legitimate traffic gets flagged as an attack. Or worse, new types of attacks are completely ignored.
Precisely. Which means a system you designed to be perfectly fair and accurate slowly begins making financially damaging or biased decisions entirely under the radar.
Which is why passive monitoring is never enough. You need automated systems tracking performance metrics in real time to catch that drift.
Yes, and you also need active adversarial testing, often called red teaming.
Like hiring a team to actively attack your own system.
Exactly. Trying to trick it into hallucinating or bypassing its safety filters, you have to expose those weaknesses before bad actors, or even just shifting market trends, do it for you.
That level of continuous, aggressive monitoring isn't just about internal peace of mind anymore, though. You don't just do it to feel safe. You do it because global regulators are actively watching.
Oh, absolutely. The internal technical practices we're discussing are now directly tied to external business survival. The grace period for AI experimentation is effectively over.
Ignorance of how your models operate is no longer a valid legal defense.
Not at all. Römer outlines several key global standards that function as the new map for corporate compliance. You have the NIST AI Risk Management Framework in the U.S.
Which provides a highly respected methodology to map, measure, and manage risks, right?
Right. And then there are the OECD AI principles updated in May 2024, actually, which focus heavily on accountability and human-centric values.
But it's the EU AI Act that really forces a change in day-to-day workflows, doesn't it? It introduces those strict risk tiers.
It does. If your AI falls into a high-risk category like biometrics, employment sorting, or critical infrastructure, the documentation requirements become immense.
It dictates human oversight mechanisms and carries massive financial penalties for non-compliance. So what does that actually mean for an engineer on the ground?
For an engineer, it means you can no longer build a black box. Your workflow has to include building mandatory logging capabilities, running robustness testing against specific attack vectors,
And creating user instructions that explain the model's probabilistic nature to the end consumer. It turns abstract legal requirements into daily engineering tickets.
Exactly.
Looking at the U.S. context, there's the Executive Order on Trustworthy AI from late 2023 pushing federal agencies to enforce similar standards. But Römer brings up a very specific banking precedent. SR 11 to 7.
Yeah, SR 11 to 7.
It demands intense model inventory and validation. But I have to push back here. If I'm listening to this and I run a mid-sized e-commerce SaaS business in the US, why should I care about banking regulations like SR 11 to 7 or the EU AI Act?
It seems totally disconnected until you look at the modern digital supply chain.
How so?
Well, banking is a high-stakes, hyper-regulated environment, which means their risk frameworks are years ahead of everyone else. SR 11.7 is essentially the canary in the coal mine for AI governance.
So it's a blueprint that other industries can adapt right now.
Exactly. The rigorous model inventories and continuous validation it demands are becoming the gold standard across all industries. And you also have international moves like Canada's directive and China's 2023 interim measures.
And enterprise clients are going to demand those standards from their vendors.
Precisely. If your SaaS platform processes data for a multinational corporation or an EU citizen, you are pulled into their compliance orbit. They will demand that you, as their vendor, provide the exact same level of auditability they are legally required to maintain.
So adapting internal policies to these frameworks now prevents surprise workloads later.
Right. If you use SR 11.7 as a blueprint to adapt your internal policies now, you are building a massive strategic advantage. When local agencies eventually publish their binding rules, your competitors will be scrambling with surprise compliance workloads, and you will already have the infrastructure in place.
Okay, so understanding these global frameworks is the theory, but we have to translate that into daily operations without grinding the company to a halt with friction. How do we operationalize this operating model?
You have to recognize where you are on the maturity curve. Most organizations begin with informal values, just a corporate statement about doing the right thing.
But you have to move from that informal stage to a formalized framework.
Exactly. The phased implementation roadmap Römer suggests is remarkably pragmatic. Step 1. Conduct a system inventory. You simply cannot govern shadow IT.
You need a centralized, updated list of every algorithm currently running anywhere in the company.
Right. And once that inventory is established, you start implementing core controls. I think the focus on visual dashboards here is brilliant.
Building visual dashboards with health scores, right? This aggregates metrics like data quality, latency, and accuracy into a single number.
The mechanics of that dashboard are crucial. It pulls telemetry from the model in real time. If the health score drops because latency spiked or a data drift threshold was crossed, the automated monitor triggers an alert.
To the specific person accountable in your RCI matrix.
Exactly. It allows the team to intercept the degradation before a customer ever experiences an impact.
I love comparing these visual health score dashboards to a pilot's instrument panel.
That's a great way to look at it.
Right. When the regulatory and technological weather gets cloudy, and it is definitely cloudy right now, you can't just fly by the seat of your pants. You need reliable instruments to land safely.
But an instrument panel is completely useless if the pilot hasn't been trained to read it. Operationalizing this model means treating data health as an organizational habit, not an isolated IT project.
Culture and training are the final essential pieces of the puzzle. And we aren't talking about a generic compliance video everyone clicks through while checking their email on a Friday.
No, we are talking about role-specific training and scenario workshops. You need to develop and maintain incident playbooks.
So when a model health score plummets, or a red team discovers a critical vulnerability, engineering, legal, and PR know exactly how to react.
Yes, you do not want to be forming an emergency task force to figure out your response strategy while the system is actively behaving oddly in the wild. It has to be culturally normal for anyone in the company to pull the emergency cord if they see an issue.
Zooming out to summarize the overarching strategic insight from this deep dive, practical controls turn ethical policy into repeatable work.
Exactly. Good AI governance doesn't slow you down.
It provides the reliable, auditable infrastructure you need to scale these tools safely, satisfy regulators, and maintain the long-term trust of your consumers. It basically takes the fear out of innovation.
By making the boundaries visible.
Well said. Thank you for tuning into the SmartKeys podcast for this deep dive. If you want to stay ahead of these crucial business trends and ensure your team has the actionable tools to navigate the future of work, make sure you hit subscribe to the podcast right now.
The full text is an incredible resource for benchmarking where your organization currently stands on the maturity curve.
It really is. I highly encourage you to read the full comprehensive article by Felix Römer to get all the granular implementation details. We've made sure that link is available right now in the show notes.
Definitely check it out.
As we leave you, we want to offer one final provocative thought for you to mull over. As we rely more and more on automated monitoring, dashboards, and automated fail-safes to govern our AI models, who or what is going to govern the AI that governs the AI?